We're continuing with Chapter R in the College Algebra textbook. In this video, we're going to flip through section R.5 on factoring. All right, so it starts by saying in section R.4, we learned how to multiply polynomials. In this section, we reverse the process. The goal is to decompose a polynomial into a product of factors. This process is called factoring. Factoring is important in a variety of applications. In particular, factoring is often used to solve equations. For example, the two equations that follow are equivalent, right? And so we'll see how this is one way you solve polynomial equations. You put the polynomial on one side, 0, and have 0 on the other side of the equation. You factor the left side, and then you can set each of the factors equal to 0. We'll talk about that later in the playlist in chapter 1. But yeah, you want to learn how to factor. You want to make sure you're good at factoring. And so we're going to focus on polynomials, but at the end of this section, we factor a non-polynomial. So the skills we're going to learn in this section, you can apply in general to any kind of expression. Like, for example, we talked about the a squared minus b squared is equal to a plus b times a minus b. That doesn't have to be a polynomial. That can be anything. All right, so it starts with factor out the greatest common factor. So if we come here, so you've got your polynomial. There's a common factor. X cubed is the greatest common factor of x, right? And then 6 is, as far as these coefficients, 6 is the greatest. So you could factor out a 6x cubed. And so that's always the first thing you're going to look for when you're trying to factor a polynomial. Or again, not just a polynomial for any general situation, but I'm just going to refer to polynomials from now on because that's what we're talking about in this section. The first thing you're going to look for is factoring out a greatest common factor. And so we're going to work a bunch of examples, and you'll see how the greatest common factor works. Factoring out a negative factor. So yeah, like if you have this, so let's come here. You might want to take out a negative. You don't have to. It just depends. So like if you take out a negative 4 here, you get a polynomial where the leading coefficient is positive, which is a lot easier to work with because a lot of the rules, the general formulas have a positive leading coefficient. So it's easier to match up terms. It's just easier to work with. All right, factoring by grouping. To factor a polynomial containing 4 terms, we often try factoring by grouping. So yeah, if you've got 4 terms, a polynomial with 4 terms, you first look for the greatest common factor, and then after that, the typical next step is to look for the possibility of grouping. And so what you do is you group like terms. So here they group the 2ax and the 6ay, and then the 5x and the minus 15y. Factor those separately, and you might get, like you see how they have this has an x minus 3y, and then this also has an x minus 3y. So then you can factor that. That's the idea. So this obviously doesn't work every time, but it's something you can try, particularly if you're taking a test. So like in real life, this probably won't happen a lot, right? It's not the most likely scenario that you'll end up, after you've grouped, you'll end up with the same factor here. But on a test where you're being tested, you're asked to factor something. If it's got 4 terms, there's a decent chance that the problem they gave you, you can solve it by grouping, okay? And we'll work a bunch of examples where we group. I mean, let's look at this one. So m squared minus 3n plus 3m minus mn. So maybe you group these two terms with the 3's in them together. You might have to try different groups, but here they do. The m squared minus 3n is grouped together, and the 3m minus mn is grouped together. And they don't do anything with the m squared minus 3n, and then they take out an m here. Right, yeah, these don't match, exactly. So they don't match, right? This doesn't work. You haven't really done anything. You haven't factored anything here. So they try the m squared plus 3m because these have the matching m's, and then the mn and the 3n. So you can take out an m and take out an n, and sometimes you'll have to play with it. You might leave a minus here or put a plus here, but you get the matching m plus 3, so now you can factor out the m plus 3. M plus 3 times m minus n, and it's factored. Okay, factoring quadratic trinomials. Next, we want to factor quadratic trinomials. So quadratic means that you're going to have the degree of the polynomial is going to be 2, and it's going to have 3 terms. These are trinomials of the form ax squared plus bx plus c, where the coefficients a, b, and c are integers, and a is not equal to 0. To understand the basis to factor a trinomial, we can first consider the product of 2 binomials. Okay, yeah, so factoring, this is, you should know how to do this. Just like factoring x squared minus 8x plus 12. I'm not going to talk about this here. We do examples in the example problem videos, but this is like basic factoring, right? X squared minus 8x plus 12, you say 1 times 12. You take this 12, so 4 times 3, that doesn't add to 8. 6 times 2 adds to 8. Okay, but so you take minus 6 minus 2, because that minus 6 minus 2 gives minus 8, and then minus 6 times minus 2 is positive 12, and you factor it like that. Okay, but what do you do if you have a quadratic trinomial, but the leading coefficient is not 1? Well, again, we're going to work a bunch of examples, but what you do is you multiply the leading coefficient and then the constant. So you say 27 times 5. All right, so 27 times 5, you got 135. Well, wait, no, hold on, I'm sorry. No, you put this, you first put it in standard form, so 10y squared plus 27y plus 5, okay? Yeah, so standard form, leading coefficient is not 1, multiply the 10 and the 5, and you get 50. Now separate this into factors, and so you can get something that adds to 27. So, well, 10 and 5, no. So what about, 25 and 2. 25 times 2, right? Positive 25 plus positive 2 adds to positive 27. And then also positive 25 times positive 2 gives the positive 50, right? If this was negative 50, like it needs to match up as well. Like if this was a minus, let's say this was 10y squared minus 27y plus 5. Well, then we'd have a problem, because you can't get, you have to put, no, we'd be okay, because we'd say minus 25 minus 2 gives minus 27, and then minus 25 times minus 2 gives positive 50. So we'd be okay, but it needs to match up that way. So once you've got this 25 and this 2, you use that grouping method where you make 4 terms, right? So you write it like 10y squared minus, and you do 2y, right? So we would do this. We would say, I'll write it here, 10y squared minus 2y minus 25y plus 5. You see? That's the same thing, right? These are the same. And I grouped the 2y, I grouped it this way because if I did it the other way, minus 25y minus 2y, well, then the 2y and the 5 don't really match up. But you might have to do it as long as this condition is satisfied. So what we did here, the grouping is going to work. The grouping will definitely work in either one way or the other, as long as what we did, this first step, is satisfied. Okay, so we do the grouping method. We factor out a 2y, and we get what? 5y minus 1. Okay, minus what? Minus 5, and you get 5y minus 1. There we go. So these two are the same. So we factor that, 2y minus 5, 5y minus 1. Wait. I'm sorry. No, I don't know why I put these minuses. This is plus. Plus and plus, right? We don't have minus 27y. So then we've got, this is plus, this is all plus. right? And so 2y plus 5, 5y plus 1. That's how you factor a trinomial, quadratic trinomial where the leading coefficient is not 1. Okay, if we come here, same thing, but this is a little bit different because we've got more than one variable. So you put this in order of degree. So this is third degree, this is third degree, this is third degree. So I mean, I guess the order doesn't matter because they're all third degree. So you'll just have to play with it a little bit. But what they do is they first factor out the first step you do for any factoring problem is factor out the greatest common factor. So they take out a 5x, okay, and they get this here. Okay, now if you look at this, you could view it like it's 2x squared, and then the x. So this is like a polynomial with a variable x. So x to the second, x to the first, x to the 0. Okay, so let's just take a look at this. This is a little confusing, but let's just look at 2 times minus 11. So minus 22. And if we want to get positive 21, we say from minus 22. So we say what? We say 22 minus 1. That's positive 21. And then 22 times minus 1 is minus 22. Okay? So 22 and 1. 22 minus 1. So just write your middle term based on what you just found. So we're going to say 2x squared, and let's put the 22 here. So 22xy minus 1, so minus xy minus 11y squared, right? Because the 22 and the 2 are divisible. Right, so just like multiply the coefficients, and then if it works out like we showed, then just rewrite the middle term to create 4 terms based on what you found. So here we can factor out on these first two, we can factor out a 2x, and we get x plus 11y. Okay, put a minus, and let's see what we have. Minus what? Minus y, and then you get x plus 11y. There we go. So now we just factor out the x plus 11y. So 2x minus y, and then x plus 11y. Right? But now put the put the 5x now. Right? We just factored this. And that's what we see here. Let's see. Yeah, 5x, 2x minus y, x plus 11y. So again, just what we did was we first factored out the greatest common factor, and then we inspected this and saw that it is in a polynomial form, right? If it needs to be some form of a quadratic trinomial. So this is x to the second, then x to the first, then x to the 0. And then there's multiply, and then you consider the coefficients, like here's a coefficient of 2. Here's a coefficient of 21y. Here's a coefficient of minus 11y squared. It doesn't matter as long as it's in that polynomial form. Then just multiply the coefficients of the leading coefficient and the last coefficient, and see if you can do that to where it equals. You can sum to this and also multiply to these two terms, and then you'll be able to group. Just use the form of the middle term to make it into those grouping of 4 terms. All right, the process to factor a trinomial can be challenging if the coefficients are large. Okay, and so you can look for a trinomial that is a perfect square. So this a plus b squared, a minus b squared, we talked about this in like, I think it was the previous section, R.3 or R.4. If you've got something in this form, then you can factor it into a perfect square, a binomial, right? So if we come here, so if we look at this expression, we see the leading term has a nice root. So we know that 2x squared gives 4x squared, okay? We know that, 49, 7 squared is 49, all right? So now just take the this times 2, right? Because the a plus b or a minus b squared, it's a squared then plus or minus 2ab plus b squared, right? So take 2 times 2x times 7. That's 28x. And it doesn't matter if this is a minus or a plus. That doesn't matter here, because now we're just going to say this is going to be 2x minus 7 squared, right? If this was a plus, it would be 2x plus 7 squared. Now, this leading term and this trailing term need to be positive, because otherwise, like, you can't say if this was minus 4x squared minus 28x plus 49. Well, there's nothing that when you square it gives you minus 4x squared, right? Other than an imaginary number. So it's not going to work, you see? Unless if you have a minus 4x squared, maybe you can factor out the minus. So if we had minus 4x squared minus 28x minus 49, factor out the minus and you get minus 1, and then times the whole group 4x squared plus 28x plus 49. And then you could factor it then. Okay? So if we look here, we inspect this and see, okay, well, 81's a nice squared number, c to the 4th. Okay, so 9c squared, all right, 25d squared, that's 5d. So take 2 times this times this. 9 times 5 is 45. 45 times 2 is 90. C squared d. There we go. And this is a plus here, so it's going to be 9c squared plus 5d squared. Okay, binomials. So if you just got a polynomial or whatever with just 2 terms, so a squared minus b squared, that's easy, right? You should memorize this, a plus b times a minus b. So if you ever have the difference of 2 squares, so here they probably factor out a common factor. Yeah, they factor out for this one, they factor out a 2, and then you get 6y squared minus 81. So that you see those 2 squares, the difference of 2 squares. So this is just the difference. If you have the sum of 2 squares, you can't do anything with that. I mean, unless you can factor out a greatest common factor. Usually you can't do anything with that. But if we come here, if you've got the sum of 2 cubes or the difference of 2 cubes, we're still talking about binomials, you can factor both of those. And so we're going to work a bunch of examples where we use these formulas. You come here, you see x cubed, you see a binomial, look for a difference of 2 squares. You see a binomial with cubes in it, then consider, okay, x cubed, this must be something cubed, 5 cubed. So you factor it with the difference or sum of 2 cubes formula. Okay, apply a general strategy to factor polynomials. Okay, let's come here. So if you're doing a factoring problem, first look for a greatest common factor. Then if you have 4 or more terms, try grouping. 3 terms, you can look for this a plus b squared, a minus b squared, or just use the general method where if you got x squared plus 3x plus 5, just the most common method for like a trinomial with a leading coefficient of 1. If the leading coefficient isn't 1, use that method we talked about where you use grouping. Okay, 2 terms, consider the difference of 2 squares, the sum of 2 cubes, and the difference of 2 cubes. Okay, factoring a 4-term polynomial, they use grouping here, right? They group the terms, factor each side, and they get a common x squared minus 9. Here, you have 4 terms, they group 3 terms together. So you get 25 minus, and they factor out a minus and get this. This they see is a perfect square trinomial. They make it this. Now you've got the difference of 2 squares. You see? So you don't have to group. You can group any way you want. You know, even if you have a 6-term polynomial, try grouping in different ways. And then so you see once they have 25 minus this squared, so now they could use the difference of 2 squares. Okay. Factoring a trinomial using substitution. So be aware of substitution. So you have something squared plus 2 times that same something minus 24, right? You could say u is equal to x squared minus 5. Then you get u squared plus 2u minus 24. Factor that, then substitute the u back in there. So always look for pattern. Like everything we talked about in this video, make that like general, make those, all those rules and tricks general in your head, and then look for those same patterns. Like here you would say, you would look for that, you would notice that pattern. It's something squared plus 2 times that same something minus 24 times that same something to the 0 power, right? And then go from there. All right, now factor expressions containing negative and rational exponents. So these aren't polynomials. And what they do is, if we come here, if you've got something like this, so but what you notice is that it's still in like a descending order. -6, -5, -4, right? I guess -4 is greater than -6, but it's in that familiar order. Try factoring out what you need to make these regular numbers, regular positive numbers. So if you factor out an x to the -6, you get this to the 0 plus this to the 1 plus this to the 2. Okay, yeah, then you reorder it. Yeah, so -4 is greater than -5 and -6. So when they factor out an x to the -6, they get this here, 7x squared plus 5x plus 2, and then they write it this way. Now, I guess they're done here. You're not going to go any further, but potentially you would factor this as well, right? And you could also look for that. You could do substitution here if you wanted to as well. You could say set u equal to x to the -6. You could just think about it. You could substitute a variable in here to where when you substitute the variable, you get 7 times that variable squared plus 5 times that variable plus 2 times that variable to the 0, just 2 times 1. So what would that be? That would be, you would say u is equal to x to the -6, I guess. Okay, no, you would say, so this is 2x to the -3 squared plus 5x, no, yeah, x to the -5 to the first. Maybe you can't do substitution. I guess you have to play with it and see, but maybe you can't do substitution. Okay, and then here they factor out a 2x plus 5 to the -1/2. So yeah, we'll do problem. We have a whole video on this. All right, so see you guys in the next example problem video.